So today let's try to fix this bread baking contraption, and in the process let's also explore what's inside of it and how does it work. There's a window, this openable door, the plug, some controls, and it comes a little bit pre-disassembled, some screws taken out because it's not working, and there is basically this tray where the bread is being baked with these stirring, mixing things, and it can be taken out. And these have these things basically meshing with these, so it's turning, and there's a heater baking it basically. Of course it has a lot of fancy controls here, some presets for the baking time, temperature, some display timer, whatever, but the basic physical things in it are just a heater and the motor. It just rotates and heats, it's all it does. And this is just fancy electronics. And it's not working, so let's open it and see what's inside of it. How does it work and if it can be fixed. Removing some screws. And the screws here were already taken out. About 8 screws, and now it should come apart. And this top with the electronics. Lifts from it. This is going to be a crappy video because it doesn't fit under the camera properly. Here are all the controls contained under some cover with some connection cable. Can I disconnect it here to prevent it from breaking it? Yes, that's the bottom of it. And here you can see the motor, which probably turns these. And some other board. There's some, I guess, the motor capacitor here. Does this come out? Yes. Of course this was on multiple screws here, but it's nice when somebody removes them for you. And then nothing else in the box. Just the cable actually going in here, so I can't completely take it out. So here's some control board. And I guess there are some temperature sensors. And there are 4 white wires and 2 yellow wires going to this, which I guess is some temperature sensor and overheat protection. Here is the motor, and of course here are the gears, and the belt is missing. It was basically 2 belts, one going from the motor to this big one as a reduction gear, and another belt going from here to basically transfer the motion to the other one here. This seems to be like a single phase motor with 2 windings. One is connected to mains and one is connected again to mains, but via a capacitor, I guess. It has 3 wires going to it. One of the windings has to be connected to a capacitor to create a phase shift, because otherwise a single phase motor doesn't start. He took the screws out of the control panel, removing the cover, and here's the control board in it, which just pops out, and here's the LCD display on it at a weird angle. Bloody hell! What's so wrong about right angles? Why can't modern appliances make more sense? Is it just me, or is there anybody else finding this absolutely ridiculous? I prefer cube-shaped or right-angle-shaped appliances over these stupid contraptions, which basically look like a blob. But anyway, you can see some buttons here, some transistors, some capacitor, a lot of resistors, and there is just one microcontroller here, no other components on this side. Some capacitor, I guess some crystal or ceramic resonator. This basically clogs the chip. Not much to see here. I will try to connect it and see if it works. The point basically is to verify that everything else works and that this contraption is worth ordering the belts for it. Of course I should stay in the view, connecting this, and let's try to power it. Let's try to power the internals of this blob and let's see what happens. There is some timer, or this is the time of baking, I guess. The beeping is also super annoying, from 3.5 minutes up to 13 minutes. What's this? Some presets, I guess. This is setting like light, medium or dark. This is powering it, I guess. It clicks and the motor is not turning, or is it clicking to turn on the heater? And this is a bad idea, but it's actually hot. I guess it's baking now, and after some time maybe it starts. Well, this is not going to turn without the belt, but the motor should start spinning at some point, I guess. Another click of a relay here. Another click. Is it cycling the heater? I connected a small lamp to the heater to have some indication when it's running, and it seems to be cycling on and off, using some thermostat or maybe just a timer, which is pulse width modulating it, and it's counting down. The lamp is connected straight to the terminals of the heater, so the heater is being switched, but the motor is not. I guess now the motor should be spinning. I guess it should blend it before baking it. It doesn't make sense to blend it after it's baked, does it? Now the motor is turning. It seems to be pulsing, like it's turning on and off in pulses. I think you can hear it. Previously the motor was running in pulses, now it's running continuously, and this happened after several minutes. It might actually work well. It's possible that it's running the heater for a few minutes just to warm it up, not to bake it. Then it starts the motor, initially pulsing it to blend it a bit slower, then it's blending faster, and finally it will bake it by running the heater for a long time. And the heater isn't running now. I guess now the motor changed its direction. And I guess the directions are switched by this circuitry. The motor has two coils and the relay selects which one is connected straight and which one via the capacitor. And this changes the direction because it changes the rotation of the magnetic field. The current in the coil connected via the capacitor is ahead of the current of the other coil. Looking at the clock and writing down when it switches the direction, it's every 2 minutes. Well, now it's beeping. What's happening now? Is it starting to bake? Not yet, the lamp is off. Was the beeping some failure, or was it asking you to add some ingredients or something? Still switching directions every 2 minutes, but the phase of it shifted a bit. So what happened so far? It was pulsing the heater, then it activated the motor and it was changing the direction every 2 minutes. It was actually doing so several times before I started writing down the times. Here was the beeping, and after a few more direction changes, the motor stopped and now it's doing absolutely nothing. The heater is not on. But I guess there is just some delay before the heater turns on now. The heater is cycling. Now it's cycling the heater about 5 seconds on, 25 seconds off. This is not going well. I kept testing it and I was almost concluding it just needs new belts, but then I could smell something burning. I was thinking it's the heater, but at that moment the heater wasn't on, the motor was on, and the housing of it got too hot to touch. I'm not sure if this is its normal operating temperature, but it reminds me of a smell of a burning winding. The motor has two coils, so let's try to measure the resistance from this to this and from this to this. Of course the question is, which one is the common? Is it the black one? 90 ohms. Here it's 96, the other one is a little bit less. And between these two, it's probably the two windings in series, yes. So the black is common. One winding is 96, one is 90 only. Does this one has short turns on it, making it much more hot? I guess it's possible when the belt broke, it winded on the shaft of the motor and stopped it. And when the motor was powered and not able to turn, it probably overheated and developed some short turns, which now make it very hot even with no load. And of course I should also measure the capacitor of the motor. It's 4 micronominal and where I measure it's extremely close to it, so the capacitor isn't bad. And of course somebody was asking me if my ring tester can test windings of motors for short turns. So let's use this as an opportunity to try it. I'm ring testing one winding, it shows just one ring, and the other one again just one ring. This is using a 100 nanofarad capacitor for the test. Now let's try to ring test it using a higher capacitance, adding this 6.8 micro capacitor in parallel, and this is actually showing 0 rings. But of course I doubt a ring tester can actually test short turns in motors, especially in asynchronous motors. Ring testers are used for ferrite core transformers or ferrite inductors or iron powder inductors maybe, or for air inductors, deflection coils, nowadays mostly for components in switching power supplies. They're not really good for iron transformers and motors. And the reason I think it's not possible to ring test the winding of an asynchronous motor is basically because its rotor is a massive bunch of aluminium short turns on an iron core. And this can't really tell the short turns in it when basically the rotor is shorted, which is basically the principle of an asynchronous motor. The Q factor of the winding in a stationary asynchronous motor is always very low. Of course, if it was a switching transformer or switching inverter inductor or something, 0 or 1 ring would indicate it's bad, but for a motor, it's probably always going to read this. In an iron transformer or in a motor, the best way to identify the short turns is based on it getting too hot or smoking or burning or drawing significantly more power or current than it should. Or if the motor has more identical windings, the windings having different resistances can be a sign of short turns. Or you could also use a thermal camera if the windings are exposed, and if there is a short turn, you could actually see some spot much hotter than some other sections of the windings. Let's run it for some time and then look at it using a thermal camera. Okay, the video is really going well now. I kept running it and waiting to either see some smoke or some hot spot on a thermal camera, but something completely different happened. I left this board on this edge, and as it was running and vibrating, the board fell down, and you can probably imagine what happened. And I guess you can actually see it. I sort of regret I don't have this on camera, but you can see the burn mark here, where it shorted to something on the chassis, and it blew several traces of the board, and it also blew a massive hole in the chip. And this is sort of my stupidity. I was seriously thinking about not even publishing this, but everyone makes mistakes and at least you can learn from them. The close-up of this chip completely blown apart. This is thoroughly done now. Okay, the good news is I have some trash donor of parts. This contraption seems to be very common in this country. The bad news is it's not exactly the same version. You can probably already see the components on the control board are a bit different. Also the motor looks different, but it's because this one in this version has this cooling impeller on it to keep it cool. If I remove it, it looks very similar, other than the shaft actually goes through it. And I was thinking, which one is actually newer? Did they actually add this impeller for cooling in a later design, or was it the other way and they cheapened out and omitted it? I was looking if I can get some date code from it, and this one says 2005. It's the design date, not the manufacture date. And this one says 2008. So the one I'm fixing is the older one, and the donor is a newer one. So they actually added the impeller, which makes me think, is the motor running super hot because it's faulty, or is it overheating because of a bad design? In either case, I was going to put the motor from this one into this one. This one is either shorted or it's poorly designed. And of course, after this incident, I can just put all the electronics from this one to this one. I could put just the control board in it, but I'm not sure the control board from this one is going to be compatible with the other board from this one, so I might actually transfer both boards. The connector is slightly different. It doesn't have this locking mechanism on it here, but otherwise does it actually fit? Well, it doesn't fit, so in either case I'm transferring both boards. Of course I could just fix this one, but it's sort of in a dumpster condition. The metal is rusted and the plastic box is quite dirty from the outside, so just for hygienic reasons I have to fix this one, or at least whatever you touch and the food touches has to stay from this one. taking the donor chassis out, and I was naively thinking I can just use all the parts I need from this donor, but then I looked at it and you can see it. This actually used to be the second belt. One is actually sort of intact here. It sort of looks like a timing belt of an engine. I guess it's some sort of a rubber reinforced with some strings, as the second one already completely disintegrated, and you can see the pieces of it in the box. Nice! And here you can really see the reason why you preventively replace the timing belt in your car. Almost all engines made in the last several decades are interference engines, and if the timing belt breaks on a running engine, the engine is just as blown apart as this chip then. Okay, so I'm not getting the set of belts from this donor, but at least the motor and, after the incident, the boards, of course. Of course, now I can compare the resistances of the windings. The previous one was 90 and 96 ohms, and this one is 125 and 119. This one definitely has higher resistances. Now the question is, does the other one has short turns in both windings, or is it a different version, or combination of both? And this definitely has to be a different version, because it also has a different capacitor. Instead of 4 micro, it's 3.5 micro. And it measures 3.55. Again, a good capacitor, but a different version of it. I'm just going to transfer all the guts from the donor into this one I'm fixing. And strangely, the motor in the donor actually looks much cleaner. In this one it's dirty, despite the chassis is the other way. In this one it's dirty and rusty, in this one it's clean. It's weird. What's this discoloration on the motor? And it looks like with some resin leaking from it. What are all this? It almost looks like it was very hot and some sort of resin was melting and dripping from it. The other one is quite clean in comparison. It really makes me think this one overheated. Stripping it completely. I hope the other motor will fit actually. That's the bloody hot motor with its 4 micro capacitor. And now this one is completely bare. Here's the comparison of the switching boards, which are different. This one is the donor. Both have 2 relays. The transformer is 230 volts 50 Hz to 10 volts 250 milliamps. This one doesn't say the secondary voltage. Both of them have similar components but in a different layout. It's using one relay for the heater, one relay to switch the direction of the motor, but to switch the power into the motor it's using a triac, not a relay. This one also has a triac. The other package is 7805. This one is using 78L05, which is the same, just in a smaller package. Both have a beeper. This one has 2 X2 capacitors, this one has 3. And this inductor, I was thinking it's a switching transformer, but it's just some interference inductor, which here got omitted with 1 interference capacitor. And these wires go to a temperature sensor here, and also 2 thermal fuses. Let's take a peek inside of the questionable motor, and then it opens. Here's the bearing, and the rotor. A squirrel cage, basically an iron core shorted using aluminium short turns poured into it. And here are the windings. It looks like each winding has 4 poles. You can see 1, 2, 3, 4 poles of one winding, and 1, 2, 3, 4 poles of the other winding. And one has a slightly lower resistance because it takes a slightly shorter path. And the black thing is the insulation between the windings, and here the wires go in. There might be some thermal fuse in it. Can I somehow measure the RPM of the motor? The motor is about 1400 RPM, and let's show it in more detail in a separate video because some people might be interested in just this. 24.22 Hz. The spare belts finally arrived, so I can just reassemble it and see. But before this, let's try to actually use a watt meter, and this time, for the fun of it, my analog watt meter, to measure the power consumption of the motor with no load. If it has short turns, it should definitely show up as a much higher consumption. And this is how an analog wattmeter is wired. You just have the current coil in series and the voltage coil in parallel, with its series resistor on this side, not this one, so you don't have much voltage between the coils. Basically bridging these two terminals here. The mains goes in here, and this goes into the load. And of course it has various ranges, 2.5, 5 amps, 2.5 is enough definitely here, 240, 120 or 60 volts. Let's plug it in and let's see. 240 volts times 2.5 amps is 600 watts. So now it's 600 watts full scale. The scale says 120, so it's times 5. Let's plug it in, and it shows about 16, which times 5 is about 80 watts. And the other motor says again about 80 watts. It's the same. And this is actually quite a lot of no load consumption, but unless both motors are equally faulty, it's probably normal for them. And it seems I was chasing some non-existent problem in these motors, and all the difference in the operating temperature probably comes just from this one having this cooling impeller on it and this one not. Now this bloody pile of components has to be turned back into a usable machine, cleaning and relubricating the shafts. And these can go in, and the motor goes in and tensioning the belt. Just for the perfection, checking the ESR of the electrolytic capacitors, and the 1000 microcapacitor is about 30 milliohms. The 470 microfarad capacitors are about 70 milliohms, which is good. The other one is the same. It's low enough. Here are the capacitors. Looking at the black gears, I might actually use these because they seem to have more reinforcement in the center. In the older ones, the shaft can actually spin inside of the plastic, breaking this around the rectangle. Let's swap it. Cleaning these. And here's the reason why we always have to use the right length of the screws. If it was too long, it would chew into the winding here. And the heater says 700 watts. And reassembling it. And this one has shorter buttons than the other one. So we have to transfer this contraption from this one to this one, which originally didn't have it. Using a slightly different version as a donor is sometimes quite tricky, but otherwise the control board seems to go in. Oh crap, now these are too long and it keeps some of the buttons constantly pressed. I shortened the buttons because the other ones have more worn off markings, and I transferred the black housing for the control board, and now it should go in better if these things in this one are slightly off, and that's it. It's funny how the logo of the maker actually changed between these two versions. And of course you're supposed not to forget to put these spacers or heat insulators under the corners of the chassis. Actually not the corners, but these four, because if they're heat insulators, they're used closer to the heater. And this also makes sense because these two posts are actually longer than the other four. And of course when you open it, these come off, so you don't really know how it was. It's such a detail, but without them the plastic might melt, and also without them the chassis is too low and the top doesn't fit onto it. And also without the spacers the wheels are just about to hit the bottom of the box. These things seem like such a detail, but they're quite important there. And on top of it, if you forget them or put them in a wrong spot, you're bending the chassis and messing the tension of the belt. Testing it using a wattmeter. This is the heater. And now it's reassembled and now it's working. Now it's back together and it seems to work, but it still has to be tested by a real life use. A lot of the programs seem to have a long delay before they start doing something, but the program 6, okay, starts blending immediately. And the programs 8 and 9, baking and marmalade, start baking immediately, and the heater is on right after the start. This is good to know for testing. 6 for the motor and 8 or 9 for the heater. That's it, and if you like my videos, please consider supporting this channel on Patreon, using the thanks button and subscribing. And big thanks to all of you who already support me, because this keeps my channel running.